Hello, everyone. This is a presentation to go along with the R Markdown document, Corona_CSSE, that you'll find on the server. Also have the same HTML. I have an HTML of the same version on the server. And here I'm just going to give some illustrative tips that help to clarify what you see in the document. Hopefully this will give you some good review on many of the data manipulation techniques that we've learned throughout the year, visualization techniques that we've learned already and that we are currently considering in Chapter 11 of Modern Data Science with R. And might also give you some ideas about projects for the course. So what we want to do is try to visualize cases of the coronavirus as they occur around the world or in different states in our country. There are a lot of organizations that are actively tracking COVID-19 cases around the world. And one of the best is the Center for System Science and Engineering. You can follow the link here if you want to learn more about them. They're located at Johns Hopkins University, and they've been doing a great job gathering and curating COVID-19 data. They also have an excellent interactive map that they have worked up from that data. We're not going to do anything here that approaches the sophistication of what they've got if you follow that link, but we will get some first approximations. They've also very nicely made their data publicly available in a Github repository, which we will be taking a look at pretty soon. I want to give credit where credit is due. The activity we're doing here today is modified from an assignment that my colleague Randall Pruham of Calvin University wrote up a couple of days ago. You can actually see his original assignment on the web, and he gives some additional background on the GitHub repo with some images of it that might be useful to talk about. You'll see from the R Markdown document that there are various packages that you're going to need for today's activity, so you want to make sure that they are attached. Okay, so when it comes to importing the data from the GitHub repository, we could, of course, just clone the entire repository, but I think for our purposes, we might just want to look at importing file by file using read CSV techniques. So let's have a look at the repository itself. Here it is. The data that you're going to be most interested in comes in this folder, CCSE COVID-19 data. And there's actually two further folders that give the data in two different formats. First of all, the daily reports folder. What you're going to have is a CSV file for every day since they started tracking COVID-19 cases. So if we were to try, for example, the most recent day, yesterday, then you get a look at a processed version of the CSV file. Every row is a region in a country on this particular day, and we show how many confirmed cases there have been up to this point in time, how many deaths there have been up to this point in time, how many people have recovered up to this point in time, also the latitude and the longitude for some central point in that region. Now, this is a processed version of the file we want. What you really would like to do is press the button raw, and you see the actual CSV file. Now, you're not going to copy and paste that file. We're going to get it programmatically using R, and for that purpose, the URL up here is important to examine. It's all very patterned. All the URLs look the same except for the date at the end. Okay, heading back to look at the other folder, the time series folder, we see that there are 3 CSV files, one for each of the measurements, confirmed, deaths, and recoveries. Let's take a look into confirmed. So once again, every row is a region in a country. So for example, Thailand doesn't actually have any sub-regions, it's just the whole country. And what's recorded is the latitude and the longitude for that region or country. And then there's a number of other columns, one for each of the dates, and the values are the number of confirmed cases by that particular day. Again, we'll be using the raw data. And what we'll note here is that the only difference between the confirmed deaths and recovered files is just this little word near the end. So that look into the repo conditions how we're going to do the import. So for example, suppose we want one of those daily reports for a particular day. Then I'll just gradually paste together the URL that we'd like to get. Let's say we'd like it for yesterday, March 17th, 2020. Then we can, let me see if I can do a focus mouse. We first of all build the base URL, and then right after that comes our date. After that comes the extension for the file, and then we'll paste those 3 together to make our full URL. I do that in pieces rather than all in one fell swoop, so it's easy for me to just go back and modify the date so I can pick up another daily report if I want it. But then your next step is to use read CSV on that URL and read the data into a data table that we're going to call daily here. It's good along the way to go ahead and rename a couple of the columns, because country, region, and province /state are not legal names in R. Let's turn them into legal names. While we're at it, let's get the time series data. So that's from the second folder, and here we again have our base URL. And then we're going to put on the file name at the end. Now the file name is a paste of a single character vector, and then a character vector of length 3 here, confirmed deaths and recovered, and then another character vector of length 1. So file name is actually going to be a character vector of length 3. So when we paste together the base URL together with the file name, we're actually going to get URL to be a character vector of length 3, one for each of the URLs for the time series data. So to get the actual data tables, one quick way to do it is just to read in from each of the elements of the URL vector. So here we are, confirmed shall be the data table that we get by taking the first element of URL the one for the confirmed table, and piping it in to read CSV. And again, let's do some renaming. And a data table for deaths and for people who have recovered will also be built in the same way. All right. So in this presentation, we'll focus on the first part of this HTML document, where we just would like to use the daily report for March 17th to make a map of confirmed cases for all the states in the United States. So we'd like to have a little look at the daily data table. And if you're working in an R Markdown document, you could use the DT data table function, as we have learned to do. But I'm quite impressed by a newer function called React Table from the React Table package. You can examine the documentation, if you like, by following this link. It has lots of cool and easy to use options. So we're going to use a few of those options here and have a look at daily. So interested in regions in the US, so why don't I just search for US. And I see that indeed the United States appears to be broken down by states. We do get a couple of non-US countries involved. Austria has a US inside it. Just ignore that for the moment. So our initial look suggests that what we ought to do is take daily and just filter for a country or region to be equal to, quotes, US. And then let's take a look at the results. And one thing I noticed down at the bottom is it says there's 56 rows. And gee, with 50 states in DC, that should only be 51 that we want to actually put on our map. So what's with the extra stuff? If you page through, you'll see some things. I'm just going to go ahead and do a bit of a search. Turns out that a couple of cruise ships that eventually docked in the US got included as regions inside the United States. And you got places like Guam, or the Virgin Islands, or Puerto Rico that won't show up easily on the map we're going to make, so we're going to need to get rid of them. So I form the character vector extra here, where I just stick together all of the regions that I identified I don't want on the map, and we take US and filter it down for province or state to not be in extra. Now, one thing we notice about the locations here is that the name of the state is given in full, but when you make maps, it's often useful to have something more in tune with what the mapping functions are liable to be able to recognize. So you might want the official two-letter abbreviations for your states, or even what's called their FIPS codes. You can look up about FIPS codes on the web. Here are FIPS codes for the states. So you could find on the web the abbreviations and the FIPS codes, and you could just scrape from the web and then join to the table you've already got. But on our studio server, we happen to have a package called US Map, and it's got a data set in it called StatePop. So if you use the data function to load that into your R sessions memory, then you can take a little glimpse at StatePop and see that it's got the FIPS and the short names, as well as the long names called full. So let's go ahead and do a join. So we'll just take US, and let's go ahead and rename the province or state to be full so that we can easily do an inner join with state pop on the variable full, and then just select out the variables we would like to ultimately work with. Now, looking ahead to using interactive graphics with Plotly, why don't we also go ahead and create a new variable called hover, which shall be gotten by gluing together the state name, full, with the number of deaths so far and the number of people who have recovered so far. And you might wonder, hey, wouldn't we also want to have the tooltip talk about the number of confirmed cases so far? We'll see how that gets worked in just a minute. The question becomes now, how do you take this US table and make a US map out of it with Plotly? So if you were to Google things like Plotly, United States map, you're quite likely to land on some examples that will help you. I happen to find one in the Plotly documentation. So if we follow that link, we get up to here, and you actually see an example of a map of the states of the United States of exactly the sort that we are looking for. Here's the code for it. And so one can copy that code and read it enough to understand it a bit and modify it. And that's just what I've done right here. Of course, those of you who are choosing Plotly as a project for the course are probably reading the online book about Plotly and getting a deeper understanding of how Plotly works instead of just flying by the seat of your pants, as we often do. So here's my modification of the documentation on the web, and it works out quite nicely, as you can see. So sure enough, the current hotspots in the United States are New York, with 1,706 confirmed cases so far, 13 deaths, and nobody recovered yet. So we see that Plotly has automatically provided the confirmed value without our having to write it into a tooltip. That's the number on the top. The other two hotspots, of course, are the state of Washington and the state of California, although most of that, of course, is concentrated around the Bay Area. Here's Kentucky, 26 cases as of yesterday. I left the toolbar in this particular plot because it's useful to zoom in if you want to click on some of these smaller states in the Northeast. That's all for now. The second part will examine time series line plots.